Hello, calculus students. Welcome to another online lesson. Today we'll be talking about writing vector equations and what exactly parametric equations are. And we'll know we're successful when we can interpret vector equations to identify things like starting position, final position, and speed. To start with, we have some terms and notation. Again, the first part of our learning intention stated that we will know how to write the vector equation of a line. As you can see here, this is the general form of a vector equation for a line. It's used for both 2D and 3D vector equations. R is essentially your variable matrix, or variable vector, if you will. Um, you can see here that R contains your X or your Y, X and your Y components, essentially, and if it's in 3 dimensions, it'll have X, Y, and Z. A is essentially a position vector, and you're given an ordered pair, X comma Y. Often we'll refer to that as the starting position vector. In a word problem, if we're using a equation of a line to represent something, there's always a starting point and then eventually an ending point. The B vector, and again we can see the B is bold but the T is not. The B vector is your directional vector. It tells you where you're going. It's sort of like your slope. We often refer to it as your velocity vector because not only does it tell us where we're going, but it tells us how much movement is happening, so that controls the speed. We end up with our final position vector, once again being R, R being that unknown vector containing x's and y's and or z's if you're in 3 dimension. And if you know how much time you've been traveling, or your variable there, t, which can be exchanged for other variables as well. You plug that in and you're able to solve to figure out what r is. We can break up any vector equation into separate parametric equations. You'll notice here at this first bullet point, you have your x is equal to this little equation here, a sub 1 plus b sub 1 times t. And then you also have a y parametric equation right here, which would include y equals a sub 2 plus b sub 2 times t, and those are written out for us here. So it just breaks it from its component form, or it could even be written in unit vector form, and then just translate it into separate equations for x and y, and in 3 dimensions we would also have z, and we'll talk more about that later. So to start with, we are asked to find the vector equation as well as the parametric equations of the line passing through the point 1, 5 with the direction 3, 2. Again, we want it to be in this form, r equals a plus t times b. Again, where r, a, and b are vectors, p is our scalar. And so we can start off with r. This is in 2 dimensions we see. And so we will start off with our r vector just being the x and y, our unknowns. A is our starting point for a position vector, and the point that we're given is right here, 1 comma 5. I'm just going to write that as a position vector in component form, so 1 over the 5 plus t. And then we have our directional vector, which is 3, 2. Now, what is this useful for? Well, obviously, we have a point right here, which is 1, 5. And if I want to find any other points on this line, I can plug in different values of t. For example, if I plug in a value of 1 for t, I could take that 1 and distribute it. Well, let me write it out. So then we would have 1, 5 plus 1 in place of our t, 3, 2. If I distribute that 1 essentially to the 3 and the 2 in there, I would end up having this 1 plus that 3, this 5 plus that 2, which would give me a new position or a new point on that line of 4, 7. I could then plug in a different value here. Get rid of those, and now let's plug in a 2. Now I do 2 times the 3, which gives me 6, plus 1, which brings me up to 7 here. 2 times the 2 here becomes 4, plus that 5 becomes 9. And I've got another point on my line, and I could do this all day long. It's a line, so you plug in a different input, you get a different output, which will be a new point. vector equation. So that's the first part. Now the second part is we still had to write our parametric equations. Parametric equation, all you have to do is break apart your vector equation. I'm going to start with the x parametric, or the x parameter. So I've got x is equal to, and I'm just going to sort of follow what I've got here. I've got a 1 plus a t and a 3 getting multiplied. We usually put our scalar first, or our coefficient, and then our variable. So x equals 1 plus 3t. I can do the same thing now with y. Try it on your own. Again, we've got our 5 here. So 5 plus, and then the 2 and the t are getting multiplied together, so 5 plus 2t. And that'll give me the same information that I just showed using the original vector equation. Now we can use these vector equations to represent things in word problems. Here I've got a particle that's traveling. This particle moves such that its x component in terms of t is 2 minus 3t. Its y component in terms of t is 2t plus 4. T is in seconds. Find the initial position of p. Well, the first thing I'm going to do for part A is write this as a vector equation. To start off with, I'll have my r equals a, my initial point, plus t times b, my directional or velocity vector. So for r, we have my components, my x and my y components. So I'll have x, y equals, a is my starting point, which in this case I can see illustrated here with a positive 2 and a 4. Now why did I pick the 4 rather than this 2 in front of the t? Because again, the point that's by itself, the constant, the thing that's being added on that's not the coefficient of t, that's your starting point, and the t is the one that affects direction. So I've got 2 and 4 as my starting position. Now I have my plus t. It's easy to find which ones go with t because they are the coefficients of t. So I see a negative 3 that's getting multiplied here on my x, and then a positive 2 that's getting multiplied with the t over here for my y. And that would be my vector equation. It's not asking for that, it's asking for the initial position. Well, the initial position is this right here, the point that we were given. So 2, 4 could be written as an ordered pair or as a position vector 2, 4. Part B says find the speed of B. Well, speed is like velocity, which is like magnitude. So we take the directional vector, not the point vector, but the directional vector, and we do the magnitude. So all we have to do is radical negative 3 squared plus 2 squared, and I end up with radical 9 plus 4, which is radical 13, and we were dealing here with meters per second. I think we'll save this example for later, and we'll go straight to the assignment here. We have a test next class on 3D vectors. From the book, though, I'd like you to look on this new material for page 325, numbers 2 through 4, and number 6. And then on page 30, which actually does some of those examples like our second example, where you're actually doing equations with a purpose, direction, and things like that, will be page 330, number 2 through 4.